Yo, what is going on, guys? Aspect Game back once again in GTNH, and today we start up UV. So there's a bunch of cool stuff I want to do. I'm going to use the quest book as a suggestion for now, but I don't think we're ready to start a lot of the more complicated UV things yet, like the new wetware circuits or anything like that. I'm not ready for that. So we're going to just start going through the crafts. I have some plans for what I want to do. I want to upgrade my LSC very drastically and also unlock the Americium Meteor. So we're going to do that. But first off, let's request our first UV machine hull. So this tier uses osmium, which is a bit of a problem. Osmium is expensive for me at the moment, but we will have to cope. All right, 2 easy quests done. The machine hull and then the cosmic neutronium. So we were able to craft this already. We had the good enough coils, the good enough energy, and the vacuum freezers on ZPM. So that was just me holding the ingot. I'm working on these 2 quests right now. So we're working towards the UV assembling. We can just check that box. We have an LSAA. And then these are just waiting to scan right now. I'm working on a ZPM scanner because this IV one takes forever to scan these parts. So yeah, we're going to get rid of that pretty soon. Then what else? We're going to make it way to the energy hatch. And yeah, we'll just see where it goes from there. Now we're talking 200 seconds for each of them. Not bad at all. So we're going to let that run on the hopper, and then we will be able to add all those to the assembly lines. After programming recipes for a long time, I did an experiment with the UV motor, and it works. So my thought process was, since each of these is a full stack of 64, I shouldn't rename them because they'll just keep going to the ULV input bus. And I was correct. You don't need to rename these, and it just goes automatically. So that is the first UV motor. I like the color of these. I like that like minty kind of green. It's a good vibe. So I'm going to make the rest of these, I guess. It's just programming recipes. So I will do that. All right, it's been a couple days since that last recording. I've done some projects that are pretty boring off screen. Mostly upgrades to the universal setups over here. So what we have over here is 2 more presses. And then I went through all these patterns, or most of the patterns, and doubled them. Some of them still need some work. And I did the same for the fluid solidifiers. We now have 4 of these, and they're all running at ZPM. Pretty soon to be upgraded, but we'll run at ZPM for now. And I've added some more drives to most of these, or storage cells to most of the drives, so that they're able to more equally disperse the recipes amongst the solidifiers. Some of them still need more, but I got lazy, so I'll finish that one day. There'll be a point where those are more of a bottleneck, and I could add more later. Then I could add like 1024Ks. This is new. These are the universal hyper-intensity laser engravers. It's almost completed. I just had to hook power up, which this is my current project I'm going to work on right now. That is the base rewire around lasers. So the gist of this is that I'm going to have these lasers going through these bottom holes every now and then. So I have one here. I have one that's maybe going to go here. And then for the rest of them, we'll put them as needed, because sometimes I may have a reason to split it off again or not. I don't really know. I don't see a reason to split this off as much, so we'll just see. So coming in from the LSC, this wire is going to get broken eventually too once we're ready to swap over. But yeah, coming out of the LSC, you go to a laser target hatch, and then the source hatches are where the lasers come from. So most of these are going to have a single laser target and then multiple laser sources, and then it's going to have dynamos coming off of it to export the power where it has to go. So once you turn these guys on, just beware if you break it, it will explode. So we will be careful with that as well. So now I gotta make a decision about what to do for the cabling and then the dynamo hatches on this, which I should probably just do it and then redo it again if I don't like it, instead of thinking for so long about it. We should just do it. So I'm hoping to insert this laser source hatch real quick. I don't want to disrupt my system, so I gotta just very quickly break it and then try to place it in here. Hopefully I didn't deform this. Yeah, we're good. Okay. That's not a good sign, but okay. I guess we were just filling the buffers, maybe. That's why the EU out was so much. All right, so I colored these all white because I don't like the way that the lines on them look. So if I do this now, I will have power going through to the lasers. Yeah, the way that they like blink from the data transmission annoys me. So I colored it white because it's difficult to notice it, in my opinion. But yeah, now we have a temporary line here. This is going to supply power to the base without that having to be online. So I could actually cut this off completely now if I wanted to and start getting some cables back. So If I break this, everything should be okay still. All right, that's one project done. I've learned how to use these now. As we go, I'll add more of them, just because I don't want to do the whole base right now. We're going to do it as needed. I have to rebuild a lot of stuff, so I'll just do it as I rebuild it. Pretty much every single multi-block here is going to be moved to a new location pretty soon and paralleled. So, yeah, especially you. You're going to die right now, buddy, actually. Because, yeah, now that I have these universal engravers going to come online, this is going to stress out my power quite a bit more. And even 2 more solidifiers and 2 more presses, all of it's going to add up. And without this transformer, we might have started losing recipes, which would have not been ideal, if you know. It's not a good idea. It's not a good thing to lose recipes randomly. So I have to finish up the system and then bring it online. I will do that next, and then we'll decide where to go from there. We are officially ready to use these. So initially I had the idea to use water coming in the back here with a subnetwork and have each water type being put to an input hatch, but I changed my mind on that. I'm now patterning the water, and I added an input hatch with a fluid detector cover. Same as other universals where I have a fluid packet decoder now as well. And then this guy handles converting the item fluid into the actual fluid. So this is fuzzy card invalid packet. And then this is fuzzy card inverter card fluid packet. And that's multiplied times 8 for all of them. So we should be good to go now. Everything looks good. And yeah, I guess we could test it out. My next big craft will stress test it. So we'll see about that one. Now, given what I was doing with these recipes, I probably want to upgrade my water next, or my cutting machines, one of the two. I'll do some research in the Waterline. It's going to take a minute for the stuff to craft probably, so we can even stress test that with those. Also, I need to build more assembly machines for the circuits, the circuit assembly lines. These are inexcusably slow. I felt that this was a more pressing bottleneck, so I went and made more cutting machines first. I have 2 quad sets of cutting machines now. And these guys are pretty cool because I'm using a new technique here. So I have a fluid storage bus on a P2P tunnel, which this is the P2P input tunnel right here. And then the fluid output tunnels go to 2 different input hatches over here, which are kind of hard to see. But yeah, I clicked on it. It's in the middle there because it's shared by all 4. And then it'll be split evenly between those 2 because it's 2 P2Ps with 2 different outputs. So it'll only have one place to push fluids, which is into this fluid P2P tunnel. It'll split it evenly, and then they'll all run parallels. Because right now, I don't have any stocking input hatches, so that's the way we have to do it right now. So we have a stocking input bus up here. This is on auto pull, and then we're just going to send things into the cutting factory. I guess I need a drive up here with a couple storage cells as well. That's no big deal. I'm out of 1024s. Maybe it is a big deal. But the other cool thing is that it's infinitely expandable now in terms of patterns. I don't know how many patterns we'll need in the end, but we can add as many as we need over here. And we can just keep this going up and up and up. So that'll be perfect. Yo, why is this an LUV target hatch? I should be using ZPM lasers, not LUV. That doesn't make any sense. Why did I do that? I guess I might have just had those crafted already. Alright, well, we're using ZPM now. I'm going to start crafting those because they're easily affordable. I don't know why I did that. Okay, we're correctly on ZPM now. Underneath here, we have the ZPM laser line going in now. This has 2 ZPM 64 amp dynamo hatches coming out of it. One of these is going to the MCRs. The other one's going to the cutting machines, the assembly lines, and the compressor over there. So I need to move my recipes over to this. I'm going to also use the... I'm going to pattern the fluids for this as well, so things like lubricant. I think it's just a better practice instead of using like an ME fluid export bus. It's a difficult question for the cutting machine because you need lubricant like by default most of the time. But I just like having an autocraft instead of having something passively running. I'm just anti-passive. I don't know why. When I tested this out, it didn't notice that the input hatches were successful places to input fluid. So I just threw a quantum tank here in between. So the fluid storage bus instantly sends it to the quantum tank, and this gets pumped out with a very fast pump instantly to both outputs. So minor change there, but not a big deal. So with my upgraded cutting machines, which are very overkill by the way, just watching these go, I can actually request my first ever UV energy hatch. These are now running at a high enough voltage to cut the Pico power ICs. So yeah, now I'm not looking that overkill, because that's actually using all the power right now. And there we go, it's almost done. Absolutely massive. Now, by some people's standards, we are now officially UV. By my standard, we've been UV for a little bit, but that's cool to do. So that quest is done. We can keep moving forward. I can make this guy now, it looks like. I gotta program some more recipes to get here, but that's the tier 5 water. I like the cadence of doing a couple water tiers at the same time. So let's probably go to tier 4 and 5 and do that. I can also do quantum computer. I feel like the water is something that I'll put off if I don't do it now, so maybe we should get on this instead. All right, tier 4 water it is. We will not put this off any longer. So this is the pH neutralization purification unit. Based on the name, you kind of guess what's going on here. So the pH initially starts at a random value between 4.5 and 9.5. I have to be within 0.05 of 7 at the end of the cycle. And then the recipe will always succeed in that case, otherwise it will always fail. So I have to use pH sensor hatches to read the current pH value, and then the machine will shut down when it goes to 0 or 14, so you just can't overkill it, which you don't really want to anyways. So I have two pH sensor hatches here. This one is at 7.05. This one is at 6.95. So this one is saying if I am below 6.95, emit a redstone signal. This one is saying if I am above 7.05, emit a redstone signal. So I believe that's correct, right? If it is above, if it is too basic, I want to add acid, which is HCl. So hydrochloric acid lowers the pH value. Okay, that's correct. So then on this one, this redstone signal is on when it's low. That means that sodium hydroxide will raise the pH. Okay, yes. See, you don't even gotta read the tooltip, you just understand a little bit of chemistry. So now, this is gonna be calling for sodium hydroxide. So I'm gonna have an apparatus that will deposit sodium hydroxide. It checks every second and it consumes, and then how much does it change it by? Every second, it consumes all the sodium hydroxide or hydrochloric acid, and it will either raise or lower the pH by 0.01. So the question is, how much do you want to change the pH by each time? It's a tough question actually, because if your initial pH value is worst case scenario, you have to be able to make it by the timer, the 2-minute timer. But you also don't really want to overshoot because then you're wasting materials. So let me think about that. That's a good consideration. Yeah, it looks like I solved this. So the way that I'm doing the items is more complicated than the fluids, I guess, but they both have the same properties. The main goal is to get the pH to be neutral, as we know, so we can make adjustments. So I've calculated that I want to make adjustments by 3 items or 30 liters each time. That will give me plenty of time to reach the threshold of the pH, even in the worst case scenarios, and then it'll very gradually do it so that I won't be overshooting and wasting materials. So the way I solve this, I have a chest buffer here, and then a brass item pipe. The brass item pipe moves 1 stack per second exactly. So that's what I wanted to do. The stack size is regulated. So the reason for a chest buffer, this is like an ancient technology. These aren't used very often as far as I've seen anymore, but these can regulate stack size output, which is why I chose it. And in this case, I want to set the stack size to 4. So we will put that there. And they say they have a voltage, but they don't need voltage. Just give them a redstone signal and they'll go. So I have a machine controller on this, enable with redstone. And once this is enabled, it will output items in stacks of 3 into the pipe, and then the pipe will move them down one by one. So that will work out perfectly. This is even easier actually. The fluid regulator has to be on conditional machine processing state. And then same thing, enable with redstone. The regulator, I didn't need an IV regulator, but set at 30 liters per second. And yeah, that'll make adjustments very slowly as well. So there's an extra part of this control circuit as well. When the pH is 0, or rather when the machine is shut off, it assumes the pH is 0. So this is, of course, reading that I am below 6.95. So we have an AND gate here. The AND gate just goes to whatever turns your machine on. In my case, it's a lever for now, but this will be a control circuit very shortly. So let's do a demo. You'll flick the lever, and then this will start slowly moving items over. If the output is facing the correct direction, that is. There we go. So now this will start putting items into the item pipe in stack size 3. and they get placed in here each second. So these will be consumed rapidly in the actual process because it consumes them once every 20 ticks or 1 second. So yeah, perfect. This is understandably a ridiculous jump cut to make, but this is the new control circuit for the Waterline that I'm working with. I did not invent this. This is copied from Dr. 9 for the most part. It's just my take on it. So to explain what's going on here is two parameters that are being controlled. Number one is the amount of each water. So I'm asking the question, do I have 10 million of the water grade? If the answer is no, it allows the line to run. But there's a second layer that allows the lines to run. So on the highest tier of water, if it's able to, first off, have enough of the previous tier of water, which in this case is 1 million, and I don't have 10 million grade 4 water, you will be allowed to run. Now, what's going on here is the highest tier of water will run if it is able to. And that's the second part of the control circuit. That's this back line here. So this one is not powered, therefore this redstone torch is powered, which illuminates this line with redstone dust. And what this line is doing is essentially, it's a repeater line going down, which locks all of the other lines that are controlling different grades of water. So I hope I'm explaining that okay. But what's going on here is that this has redstone torch lit right now. Therefore, this redstone powers this repeater, which goes down the line powering every repeater. And because this block is powered, it transfers signal downwards, which powers this repeater on each of these lines, which locks the line with redstone. So let's say this were to not be illuminated. It'd go to the next line. So now line 3 is capable of activating. But now let's say line 4 wants to activate. It'll go to grade 4. So this will work with all the different grades. We have it set up that we can just drop the torches in when we're ready, and then it will be able to run. So now up on our surface, this should be finishing up right now. This guy is able to maintain its pH very well. I've already double checked it. So we should be having our first grade 4 water, if I'm correct. It'll take a little bit longer. I just started this. All right, so I've learned it is not acceptable for the pH to be exactly 7.05 or 6.95. So I slightly adjusted these numbers up and down 1, basically. So that's 7.04. And this is 6.96. I think this should work correctly now, but I will keep an eye on it to make sure that the pH does not go out of control. But yeah, that'll be it for today. I'm going to grab my grade 4 water. There we go. I'm going to scan this. And that's it. Next time we'll keep going with the water line, and we'll find some other tasks to do, because there's plenty of work to do around here, I'll tell you that much. Yeah, until next time, guys. Thank you all for watching, and have a good day.